Hello, dear friends. Today we will discuss the concept of factorial. Factorial is always of positive integers. In counting, we have numbers. Numbers are of uh, many categories like zero, positive numbers, negative numbers, fraction numbers. So, factorial is always of a non-negative number. It means that we can define the factorial of 0, factorial of 1, factorial of 2, factorial of 3, and so on. For example, factorial of 0 and positive numbers on the right of 0 can be defined, but there is no concept of factorial of negative numbers. So here we will define the factorial of positive integers n. N is the product of n and all smaller positive integers. Uh, Here author is want to saying that whenever we define the factorial of a number n, this means that it is the product of n together with the numbers which are less than n and up to 1. So at 1 we stop this procedure, and mostly I am going to tell you the example of factorial, that if we have a number n is a positive integer, then its factorial is denoted by n factorial, like this sign, which is known as sign of exclamation, which is mostly used in English language for representation of joyness or happiness, like this. So this is the examples of 1 factorial is equals to 1. This is the property of factorial, that 0 factorial is also 1 and 1 factorial is also equal to 1. Similarly, 2 factorial is equal to 2. And how 2 factorial is equal to 2? We count them to descending order. Like that, 2 factorial, first of all, we write 2 and dot means multiplication and multiply it 1. So we get answer 2. Secondly, 3 factorial. What is the value of 3 factorial? Answer is 6. And now our question is how the value of 3 factorial is equal to 6. So we can write 3 factorial as 3, 2, and 1. So 3 factorial is equal to 6. Next is the 4 factorial. 4 factorial is equal to 4, 3, 2, and 1. So 4 threes are 12, 12 twos are 24. So answer is 24. 5 factorial is equal to 5 factorial is equal to 5 multiplied by 4 multiplied by 3 multiplied by 2. 5 fours are 20, 23, 20 multiplied by 3. These are 60, 60 multiplied by 2. This is 120. So 5 factorial is equals to 120. Next is 6 factorial. 6 factorial is equal to 6 multiplied by 5 multiplied by 4 multiplied by 3 multiplied by 2 and then multiplied by 1. So 6 factorial is equal to 720. Now look at this. We have 3 factorial, sorry, 2 factorial is equal to 2 into 1 factorial, because 1 factorial, the value of 1 factorial is also 1. So we can write here 1 factorial in place of 1. Next, in the similar fashion, we can write 3 factorial is equal to 3 to 1, and last two digits can be written as 2 factorial. So 3 factorial is equal to 3 dot 2 factorial. Next is the concept of 4 factorial. 4 factorial is equal to 4, 3, 2, and 1, which is equal to 24. So 4 factorial is equal to 4 dot 3 factorial. So this is the concept of factorial in term of factorial. Next is 5 factorial. 5 factorial means 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. This is equal to 120. And in the similar way, 5 factorial is equal to 5 dot 4 factorial. Similarly, 6 factorial is equal to 6, 5, 4, 3, 2, 1. And in the similar way, we can write it as 6 factorial is equal to 6 dot 5 factorial. The reason is that we can write 5, 4, 3, 2 into 1 as 5 factorial. Now look at this. This is for positive integers n. Here, point to be noted is that whenever we are saying about 3 factorial value, this is equal to 3, and then 1 minus 3. Sorry, 3 minus, we subtract 1 from this number, so this is 2. Whenever we are talking about 4 factorial, then 4 factorial is as it is, and then 4 minus 1, this is equal to 3 factorial. Similarly, 5 factorial is here, and 5 minus 1 is 4 factorial. So similarly, this is question. 6 factorial means 6 is as it is, and we have write it as subtracting 6 from 1, 6, sorry, subtracting 1 from 6, this is 5. So 6, 5 factorial. In the similar way, whenever we are going to define n factorial, the answer is n will be similarly come, and here it will be n minus 1 factorial. Here is the question that n, why 0 factorial is equals to 1, and we know that n factorial is equal to n into n minus 1 factorial. You know, this concept is true. N factorial is equal to n times n minus 1 factorial. If we put n is equals to 1 here, then 1 factorial is equal to 1 into 1 minus 1 factorial. So 1 minus 1 factorial is 0. 0 factorial multiplied by 1, this is equal to 1 factorial is 1, and 0 factorial is equal to 1. Next is evaluate. Evaluate means we have to find the value of this value. This is 8 factorial over 6 factorial. This is factorial notation. Now we convert it into a simple form, which is called a number form. So we can write 8 factorial as 8.7.6 factorial over 6 factorial. These two values are cancelled out, and 8 sevens are 56. So this is very simple. And right here we can see that we have break down 8 factorial, but we have not touched 6 factorial. The reason is that 6 factorials are cancelled out if we break 8 factorial, for example, bigger value. If we break the bigger value, then smaller can become. But if we break 6 factorial, which is smaller value, then 8 factorial does not becomes from here. So we have to break the bigger value. That's why answer is 56. Next is write 8, 7, 6 and 5 multiplication is here, and we are set to write this expression into factorial form. So this is the converse of this problem. Here we are given 8 factorial and 6 factorial, and we have to write this number in form of without factorial. But here we are given a number in form of without factorial, and we have to set that convert this number in form of factorial. So we know that 8765, here we have multiplied with it with 4, 3, 2 and 1. So what is the reason for this multiplication? Answer is that we have to convert this number into the factorial form. So a factorial form will be possible if we write it as 8 factorial. So 8 factorial, in order to make it 8 factorial, we need 4, 3, 2, 1. That's why we have multiplied this with this number, this term, you can say, or you know, if we have multiplied this number with that term, then we have to divide it also. So we have divided also this number with 4, 3, 2 and 1. And you know that whenever we are closing this, then look at this is the biggest number, which is in first in the form of first term. So this is 8, so this will be equal to 8 factorial, and below 4, 3, 2, 1, this is 4 factorial. So this is the concept. Here we were given the number in the form of factorial, and we have convert this number in the form of free from factorial. But in this situation, which we have discussed in example number 2, this is the this is the converse of above situation. here was factorial, and we have converted this number into a form which does not contain factorial. But here is the question which is without factorial form, and we have converted this number in form of factorial. So we can go from factorial form to a form does not containing factorial. In the similar fashion, the terms does not containing factorial, we can go from here to the form which contain factorial.